Today, class, we're going to be learning about equivalent fractions. The objective of today is to use pattern blocks to find out equivalent fractions. So, last week we learned about the different shapes that we use for equivalent fractions, and so we're going to press them here. So, the first one is what?
Rhombus.
A rhombus. Great. Second one, this one would be?
Trapezoid.
Great. Now, walking over here, the yellow would be what shape?
Hexagon.
Hexagon, correct. And then last but not least, the green shape
Triangle.
is a triangle. Great. So now that you remember what all the different shapes are, I'm going to invite one of you to come up to the board to match the fraction with the shape. This is a review of what we learned last week. Great job. Thank you, Rashonda. So from that game, we were able to see that when the yellow hexagon is equal to 1 whole, the blue rhombus is equal to 1/3, the red trapezoid is equal to 1/2, and the green triangle is equal to 1/6. So next, we're going to watch a short little video that's going to help us learn a little bit more about equivalent fractions. Then 2 blue rhombuses will equal 2/3. And then we can use 6 green triangles to equal 4/6. From this picture, we can see that 4/6 will be equivalent to 2/3. So, we were learning a little bit about equivalent fractions, and you saw some of the ones that were in the video. Who can tell me, using words or numbers, what an equivalent fraction is? Rashonda, would you like to give us an example?
Right? Using numbers, I would say 1/3. I'm sorry, 1/2
1/2.
is equal to 3/6.
Great. Good. This is a perfect example of an equivalent fraction. Stephanie, would you like to use words to tell us what an equivalent fraction is?
2 fractions that look different but are the same.
Great. 2 fractions that look different but are the same. Great. And some of the ways that they're different are the numerator and then the denominator. So, one way that we can determine if a fraction is actually equivalent is if you multiply the top, the numerator, or the bottom, the denominator, by the same number. So here, using the example that Rashonda gave us, if you multiply the numerator on the first fraction by 3, you get 3. If you multiply the bottom number or the denominator on the first fraction, you get 6. So we know that these 2 fractions are equivalent. So this is our first question of the day. So 3 triangles are what fraction of a hexagon?
1/6.
3 triangles?
Oh, 3 triangles, 1/2.
1/2. Good job, Stephanie. Next, how many trapezoids are in a hexagon? Rashonda?
2.
2. Great. So, using this information from the second question, the trapezoid is what fraction of the hexagon?
1/2.
1/2. So if we know that one triangle is 1/6, then that means that 3 triangles are what?
3/6.
3/6. And so what does this tell you when we think about the triangles, the 3 triangles, and their equivalency to the trapezoid?
3/6 equals 1/2.
Great. So next I'm going to click on this blue board and see if you're right. Great. So we have 3 triangles over here, so 3/6. And on the other side we have 1/2. And this was the equivalent fraction that Rashonda gave us earlier. So next, how many triangles are in a rhombus?
2.
2. Great. And so you can draw a line here, and you see that there's one triangle here and the second triangle here. So what fraction of the rhombus is the green triangle?
1/2.
1/2. Good job. So if we know that one green triangle is 1/6, then how many is 2 triangles?
2/6.
2/6. And so then if we were to click here, we would know that 2/6 is equivalent to 1/3. And as you can see here, we know that there's 2 triangles inside of a blue rhombus. So now we're going to take a little step further. And so what would happen if 2 hexagons put together became the new whole? So can I invite one student up to the board to give me the new fraction for the trapezoids? Great. So how many trapezoids do we see in the new whole? 4. So that means that the new fraction for the trapezoid will be 1/4. And then the new fraction for the triangles would be 1/12, because we'll be able to see that there are 12 triangles in here. 1, 2, 3, 4, 5, 6. And then there's 6 on this one for a total of 12. And then for the blue rhombi, the new fraction will be 1/6. And I'll draw it on here so you can see it. So one blue rhombi, there's 2, 3. So you have 1, 2, 3, 4, 5, 6. So now our new fraction for the rhombi is 1/6. So if the double hexagon becomes a new whole, then now we know that the trapezoid becomes 1/4 and the triangle becomes 1/2. And we talked about this before, that if 3 triangles are equivalent to 1 trapezoid, then what equivalent fraction could we use to represent that?
1/4 equals 3/12.
Good. Do you want to click on the blue square and see if our answer is right? Great. Alright, so this is a great game or a tool that you can use online that teaches you more about pattern blocks in case you don't have them at home to use. So we can put a hexagon here, and then we can use the triangles to put in here as well. And so now we see that there are 6 triangles inside of a trapezoid. A hexagon. So let's imagine that we had 3 triangles. Let's pretend right now that this is a green triangle here. what shape could we use, and then what fraction will represent the three triangles and the equivalent fraction.
One trapezoid.
A trapezoid. Great. So what fraction do the three triangles represent?
1/6.
3/6, because there's 1, 2, 3
Oh,
triangles.
3/6.
And this one represents what?
1/2.
1/2. And so now we know that these two fractions are equivalent. So now I'm going to erase all this and then have somebody else come up to the board and give one more example, but this time we're going to use a double hexagon. So now we have two hexagons, and we put them together. So you can come to the board and either move the shapes or draw the shapes to show a new equivalent fraction, because this is one whole. Stephanie, look at you raising your hand. Come on up.
Show that. So put these. Like here.
Yep.
So then this one would go. Then you have 4.
Yeah, so then you would have 4. So then we would know that 4/4, because there's 4 and each trapezoid represents 4, equals what?
2/2.
Yeah, or 1 whole, since the yellow represents in type. Great. I'm going to exit out of this. Go to the next slide. So now that we learned a lot about equivalent fractions, next week we're going to learn the same kind of thing using the same type of manipulatives, learning how to add fractions using pattern blocks.